Okay, so we're talking about types of networks. Already defined networks as two or more computers connected together to share information. Now we're talking about types of network, and the first type I'm introducing to you is PAN, Personal Area Network. Now moving on from Personal Area Network, we have Local Area Network. That's a very popular one. It connects group of computers and low voltage devices together across short distance. That's probably like within a building or between two buildings that are very close to each other. And the idea is still to share information. LAN is the most popular. And aside the fact that internet falls into one, LAN is quite popular. Okay, so that's like what you meet in most offices. Then wireless LAN. There is what's called wireless LAN. A wireless LAN is talking about the same LAN implementation but wirelessly. Did we get that? The wireless LAN is just about LAN, but it happens wirelessly. Okay. Okay, I think it's because of the fact that it rained a little bit around here, so network is a bit bad. Okay, you said LAN. Okay, okay, I'll go back. I'll take that again. Can you hear me better now? Okay, okay, it's confirmed. So let's move forward. I was talking about types of network. I already mentioned personal area network, which is PAN. It's the smallest, the most basic. Now the next one is LAN, and I mentioned that LAN is the most popular. That's the most popular type of network. That's what you see in most offices. It helps connecting. It helps in connecting shorter distance devices. The short distance could be two buildings, yes, but that's what it can handle. Even though yes, some persons have been able to extend LAN by adding repeaters or access points, but still there's a limit to how far LAN can go. So enterprise typically manage and maintain LANs. It's enough for offices to run. Who has the mic that's turned on? If you're the one that has the mic that's turned on, can you please turn it off? Because I cannot see it here. I can't see that it's turned on from here. Okay, okay. Okay, so that's for LAN, local area network. And then I talked about the wireless LAN. The wireless LAN, it functions like local area network, but uses the wireless network technology. So what you know as Wi-Fi is LAN as well. Okay. Previously, when we started networking, there was no space for. Nobody explained wireless LAN. They just did LAN and then did WAN. But thank God this is coming in now. It functions like LAN, but makes use of wireless technology. Okay, so that's what wireless LAN is all about. Now moving forward, we talked about WAN, and this is the one you should not confuse with wireless LAN, but this is wide area network WAN. Now WAN is the complex part of network connecting computers across different geographical locations, connecting somebody in Lagos to somebody in Abuja, or connecting somebody in Nigeria to somebody in New York. That's what WAN is about. Okay. Uh, allow computers and low voltage devices to be remotely connected to each other over one large network to communicate even when they are miles apart. So this is where the internet falls in. This is where the internet comes in. Of course, the devices you see in LAN are some of the devices you still see in WAN, and then add more to it. For popular devices on the LAN network is your switches, your routers, and so on and so forth. Now the same thing you see find on WAN. Now you cannot have WAN alone without LAN. I don't know if you understand that statement. You cannot have wide area network alone without LAN being included. Except you're saying all you need to do is connect to a satellite phone, and then the satellite phone connects to the person you're trying to communicate. But then you are still using some form of localized network. Okay, it's like, so we that use phones now and you're calling somebody abroad, you still have those masts, those towers that represent the cellular phone itself. Okay, so on the normal infrastructure you have LAN in the office, and the two offices in different geographical location are now connected together via the WAN. That is how that works. Okay, so this is where internet falls into the WAN. Now moving forward, we're looking at the basic network components. What constitutes a simple network? Now what you have is a computer hardware. That computer hardware can be replaced with the word device, because it mustn't be a computer. It could be a phone, it could be a microwave. We are actually handling Internet of Things, so we know it could be anything. And then you now have the cables that probably will connect them to a router or a switch or a hub or a bridge, doesn't matter which one. And then you have the network enablers, the network devices themselves. Under the network devices themselves, that's where you see the routers represented. So you have your router, your switch, your hub, and the other ones I just mentioned. And finally, you have the software itself. When I mean software, I'm not referring to the regular application that we install to use, although some of them are included in that particular place. For example, network analyzers are included in the computer software. But we're referring to softwares that enable networking. For example, a normal operating system enables networking. A normal operating system already has the TCP/IP stack, already has the protocol embedded. So that's the computer software we're talking about. Okay, so moving forward, let's see if we can break them down into different bits. I'm working with just the computer part of it. Most of other ones connect wirelessly. They don't have physical interface where you can plug a network cable. So the NIC here is talking about the network interface card. That's what the NIC is, the network interface card. And your network interface card is what feeds network to the computer. That's the module that the LAN is connected to. So, and that's what it looks like at the back of the system. If you can see what I'm displaying, you know that you have seen this a couple of times before. This is the one for desktop, and this is the one for laptop. Okay, the cable is the other one on the right hand side. So this is what your LAN is all about. That light, the light that comes with it, those two lights, the green light and the orange light, they have their significance. Some persons just think if it's showing light, it means it's working. They actually have their significance. When it's steady and green, or steady and orange, depending on the system, it means that your Ethernet cable is plugged in and connected to an active device. It means there's an active device on the other side, right? But older device, the older ones, the older systems, those colors mean something else. The orange color of the old system means that you are connected to a 100 megabytes per second network. When it's amber in color, it means you're working with the gigabit connection. That's like 1000 megabits per second. Okay, when it's green, you're operating at 100 megabits per second. Remember, it's either green or it's orange, depending on the one. But it starts blinking usually when you plug it, you plug the LAN cable, and the LAN cable is connected to maybe a switch or a router. It tells you that okay, this is working. When it's totally off, doesn't mean it's not working. Sometimes it's totally off because it's below 10 megabits per second. The connection is below 10 megabits per second. Although all of this is not important, it's just for you to be aware of it. Nobody will ask you what color is 100 megabits per second, because it can be blinking color 100 megabits and the ISP is not even giving you up to that amount. So okay, I talked about NIC. This is what an NIC is. This is what it looks like on a desktop computer. The network interface card. The card plugs into the slot and gives you the interface where you can connect your cable. And this is what it looks like on the other end, on the switch end or on the router end. You notice that the cable fits in perfectly with the clip itself. So that is basic stuff for network, just basic. We've talked about connections now, the port itself. Now what about the cable? The cable also was part of what I mentioned at the beginning. Remember, I mentioned 4 components: the NIC, the cables, network devices, and the software. So I've handled the NIC now, the hardware itself. Remember that phones have it different. Phones don't have hardware that enables you to plug cable, but phones connect to the wireless network. So phones will connect to the wireless LAN. When we get to IP addressing, I'll show you how you can attach IP addresses to laptops. I remember back when Symbian phones were reigning, Java and Symbian phones. You can set any IP address you want on your device to connect and bypass any of those standard protocols. Yeah, so now we're looking at cables. They are networking hardware used to connect one network device to another. Okay, there are 3 major types of the cables popularly used in communication. You have the fiber optics, which is the fastest of them all. Then you have the twisted pair and the coaxial cable. Okay, the fiber optics cable consists of a bundle of glass. That's the one that has glass in it. It's something high tech. It carries internet at very fast speed, and it doesn't lose it. It's lossless. It's lossless. It doesn't depreciate along the road, unlike normal cable, normal twisted pair. That the longer the cable is, the more you tendency to have slower network. Okay, the fiber optic is capable of transmitting message modulated into light waves, conversing into light waves. Your twisted pair cable, the very popular one, the one we call Cat 5, Cat 6, is a very popular one. That's the one that forms a huge amount of the one we use here in Nigeria. It's a type of ordinary wiring which we use in our homes and businesses. You have 2 varieties of the twisted pair. You either have them as the shielded or the unshielded. So when you see something like UTP, it means it's unshielded twisted pair, or STP, which is the shielded twisted pair. Now the unshielded twisted pair is the most popular of both of them. Okay, so I think I have a picture here of those cables. The coaxial, let me not jump it. It's either called coaxial cable or coax, COAX. It's a type of copper cable. It has one inner conductor inside, surrounded by an insulation. That's how you identify the coaxial cable. And it has a plastic jacket as well. Okay, so look at the picture here. You see that the untwisted, it runs free. The unshielded runs free. The shielded has another layer that shields it from transference or interference. That's how you notice the difference. It's not because of the twisting that we're calling it unshielded or shielded. Both of them are twisted as well. If you notice, if you look at them very well, you can see that both of them are twisted. Okay, so I just mentioned 4 now. I divided the twisted pair into 2, unshielded and shielded. I mentioned that the unshielded, the UTP, is the most popularly used network cable. That's where you see all those your regular category 5, category 6, and so on and so forth. The picture here still denotes what they look like after it has been fixed. The head has been connected. Now, the concept of networking has been able to silently separate or silently distinguish which colored cables they can use for specific type of network. I'm not saying it is standard, no. People just know that sometimes when you see yellow cable, it's different from when you see the blue cable. The yellow cable in a company might be used specifically for data, for storage, not to provide networking. Some companies will say, okay, let's use the ash colored one, the very regular one, to provide networking, and use the other one for storage. So you have storage area network as well. So they've been able to use colors to separate which one. So when you come into a company, when you come into an environment, when you see different color cables doing connections, be it at the back of my mind, they might not be serving the same purpose. Some of them might be because of okay, someone's asking a question. The coaxial looks like the one for dish and decoders. Not actually exactly the one for dish and decoders, but it looks like that. Yeah, it looks like that. The one that computers use is different from the regular one. Okay, someone is asking, is there any advantage of the cable being shielded and unshielded? Yes, the shielded part of it, the reason why it's a bit better than the unshielded is because the rate of loss during transmission is reduced for the shielded. If you notice the fiber optics, it has a higher shield, minus the fact that it converts it into light, into some form of light wave, but it also is shielded. The reason behind the shielding is to avoid loss. I don't mean packets jumping out of the wire, but at least interference. There's this thing that people did before that they didn't notice was a problem. You go to some old buildings that had the plan of networking at the beginning. You see them run network cable in the same pipe as the electrical cable. And then after you finish building and you're ready to start using the network, you will notice that you're not using 50% of that network because there's interference between the electrical cable and your network cable, until it was discovered before people started planning and designing their buildings differently, running those 2 cables separate. It's because the interference for unshielded is more than the one for shielded. So that's why it's different. Of course, the shielded is costlier than the unshielded. But in a place where there are no interference, in a small office, you don't actually need the shielded version of it because it's going to be doing nothing. If I'm not connecting devices that scale more than 100 meters, 50, 80, 100 meters, I don't need that one. And if I'm not running beside the electrical wires or beside some heavy duty machines, I don't need the shielded version of it. The unshielded, we get the job done. So I hope that answers your question. I need to scroll up to see if okay, no other question, so we can move forward. Okay, now network devices themselves. Network devices we talked about, I mentioned some of them. Your router, your switch, your hub. They are physical devices that are required for communication and interaction. If you are not calling them network hardware or network devices, you call it network equipment or computer networking devices, they all bear the same thing and they all do, they perform similar tasks. They are required. They are the ones that carry the transmission of data. They're the ones that ensure protocols are followed. They're the ones that ensure compatibility. That's what your network devices do. I think we'll get a time to visit them one after the other at a later time. But just know that these are the different types of network devices. You have a hub, a switch, a router, a bridge, a gateway, a modem, a repeater, access point. It doesn't end there. There are so many of them. There are more. Just that these ones are the popular ones. And the most commonly used are the ones in red, the switch and the router. The hub used to be a thing until switches came up and the hub was almost relegated. Although there are currently some intelligent hubs, but there are reasons why the hub was turned off. I'm sure you must have heard router and switch. Now there's a misconception to the word router. There's a misconception. You have a Spectranet router. There's a difference between the small device you have, that small one that has no place to plug LAN cable, the very tiny one, or that you have that small one you plug to your system to give it internet. Does not mean it's a router. I know I've heard some persons use that word. That one is referred to as a modem. It does not mean that every time you say modem, it's only that small one. There are industrial scale modems as well. Okay, so your router, there are some specifications, there are some things that make a router a router. It is not just about, it's not giving you internet. Giving you internet is just a part of it. Being able to segment packets, being able to convert from private to public, all of this are some of the functions that make a router a router. So for a picture view of what we're looking at, okay, Abdul Wasil said he has a question concerning the WLAN and the WAN. Yes, what's your question, please? Let me see if I can give you the mic. Hello, Mr. Wasil. Are you still with us? Okay, Samuel. Let's see. Yeah, all right, Samuel. Do you have a question? Hello, can you hear me? If your mic is not working for some reason, you can type the question. Okay, Aliyu Muyudin said, what category does our MiFi fall in? Okay, now it's dependent on the capability of the MiFi. That's why I said it's a misconception. It's not a mistake. It's not like we're doing something wrong. It's not like we're misclassifying it. Because those devices have different range of capability. Sometimes what we see as a router is a modem. Sometimes what we see as a modem is a router. So it's dependent on your device. For example, I know someone who calls his MTN modem. The particular one he has is actually not a modem, it's a router. It's the one that allows you to plug LAN at the back. Okay, I think somebody's mic just started working. Please take note. So it's dependent on the capability of your MiFi that we can now determine if it's a modem. Or remember that both of them can do something similar. Both of them can do something similar. Yes, the modem gives you access to the internet. Your router can give you access to the internet. Okay. Samuel is asking, okay, that he dropped his question on WhatsApp. So let me listen to that. Yeah. Okay. Now I understand the question. Now the question she asked is this: can you consider a Wi-Fi connection that connects across multiple buildings, a lot of buildings? Now the answer to this question has to do with the infrastructure on ground. For example, is there a repeater repeating that Wi-Fi broadcast in the different buildings? Is there an access point that is making that Wi-Fi broadcast go that far? Because it's the architecture that backs up the connection that determines if it falls into a WAN or a LAN or a wireless LAN as it is. For example, I cannot start confusing the MTN mast in my area and how it connects all my area to someone who decides he wants to power an estate with internet connection and goes about installing repeaters on poles, right? So when you use a repeater to connect, it's wireless LAN. You're helping the LAN out. Okay, you're helping that LAN out by repeating the network. Okay, he says just one repeater, but it connects up to the whole street. You know the length of 100 meters, right? You know the length of 100 meters. Even LAN can go 100 meters. So it's dependent on the infrastructure that backs up that thing. Now, do you know what you consider wireless wide area network? By the time someone in that particular estate is connected to somebody in a different geographical region. Now, let me give you one insight. That I summarized the types of network to PAN, LAN, and WAN does not mean there are not others in between. You get the answer now. It doesn't mean there are not other types of network in between. For example, there is MAN, Metropolitan Area Network, the one that you can use to connect cities. It's like connecting what's the nearest town to Ikorodu, connecting them together, or connecting Ikeja to Agege. So those ones fall into the metropolitan area network across multiple buildings. For example, a university campus, because of the different buildings in different places, now you have MAN as a type of network. Okay, so it's depending on the infrastructure that houses that. That's how we can tell you what constitutes a wide area network and what constitutes the LAN. But remember that they achieve the same purpose. They achieve the same purpose. Nobody's trying to test you on what kind of connection is this when the connection actually works. When there is no form of physical infrastructure housing the connection between two computers, you zero it to WAN. It means that I cannot see the router that the person in Delta State is connected to, that me I'm connected to, for us to communicate. I just zero it to WAN. Although you know that some persons run cable from state to state to enhance connectivity. Does that answer your question, Abdul Wasil Ajoke? Okay, if there are other questions, let's entertain it before we can move forward. Zaina is saying she cannot hear. Please try and refresh your browser and make sure you are using. I think the person handling the platform said Chrome does better than others, so ensure that you are using Chrome. If you are using your mobile device, please always ensure you get the desktop version of the site and not the mobile version. I think the desktop version will do a lot better. Okay, let's move forward. I just displayed the picture. You can understand when we mention a router, a modem, a switch. Some of them sometimes will look alike, so don't let the picture deceive you. Some of them actually will look alike. It's the functionality that differentiates them from a switch or a router or a modem. Okay, so some routers look like switches, some switches look like routers, and that's just it. For our IoT, we mostly work with switches and routers a lot because of how we want to get your devices connected to the internet. So because I'm going to send the materials across, I wouldn't spend time explaining all of this, what a hub is, the advantage of a hub, the importance of a hub. That's why I have them hidden. I'm going to send it to you so you can read it up and understand it better, get the real idea of what those devices do. That of a router, that of a switch, that of a bridge, for gateway, and the modem. Then for access point, and so on and so forth. So I'm going to leave it for you to read and understand it. It's when you read and you have questions, you can ask, and we'll tackle it together. Once again, we talked about the computer hardware, the cables, networking devices. I've mentioned computer software from the beginning. I don't see an extra need to start explaining it again. It's just the things that enable you to configure those networks, or things that help you manage those networks. Cisco will tell you they have CLI, command line interface, that helps you manage those networks. That's just what it is. Now let's look at networking standards, protocols, and the TCP/IP suite. Remember when we talked about the IoT standard, and I mentioned that because of the Pandora nature of IoT, it's not every nation or every government has been able to create standards. There's no generally assigned standards. Standards just come up. Remember when I mentioned the three types of standards you can have: the ones that are predicting it, the ones that would hit it on as it comes out. Those are the things I mentioned at that time. Now the internet has been around for quite some time, so the standards are ironclad. They've been there for a long while. They've been guiding the internet as it is. So there's no shaky nature of it. These protocols have been there, and you must abide by them for your device to communicate properly. Okay, so that's what we're going to be looking at: the networking standards. Now, the protocols on the internet, or the protocols guiding network, are numerous. They are numerous. So for computers to communicate properly, the computer must follow the rules of the protocol that guides that kind of communication. For example, you want to send an email, you must the device or the network must follow the rules guiding emails, the protocols guiding emails. Okay, so a single networking standard or networking protocol defines the rule for a small part. There is no one standard or protocol that defines everything. You just define the small part that you handle and let others do their own. For example, the Ethernet NIC has its own standard, has its own protocol, and we're going to be looking into all of that. Okay, so we're looking at those standards here now that's listed. On the application layer, later on we'll talk about different layers. On the application layer, you have HTTP, the Hypertext Transfer Protocol, and you have HTML, you have POP, there's actually POP3, and then you have H323, you have IMAP, there are other ones that are there, SMTP, SNMP, and so on and so forth. On the transport layer, that's where you see your TCP. On the network layer, you have IP. These are just a few of the many that are available. So we're going to be looking into some of them, the ones that are important to us. Remember at the beginning I said we're going to be looking at TCP IP because it's very important to us. And what protocols are? They are simply digital languages implemented in front of algorithms, in form of algorithms, languages that both devices will understand. Imagine how difficult it is that your HP laptop cannot communicate with your Mac system because the protocols don't match. Do you remember very well how difficult it was in the past to transfer files or share information between an iPhone and an Android phone? Thank God for things like Xender and co that started enabling such things. This is where standards are different. Now, even though the global standard for networking is ironclad, like I mentioned, is strong, it doesn't take away the fact that some vendors have their own protocols as well, and they stick to it. So a network protocol is an established set of rules that determine how data is transmitted. All these are regular definitions. Types of network protocols. I've mentioned some of them before when we talked about the application layer, the transport layer, network layer, but here they are standing on their own. You have TCP, the transmission control protocol. You have IP, that's the internet protocol, which are the two that we're going to be looking at. You have UDP. The UDP has always been there. Sometimes it's preferred to TCP. It's a sister to TCP. So sometimes people use that because of some of its capabilities. It has a better loss tolerance than TCP. And so then you have post office protocol, POP. That's the one you use for handling mails. Not just POP, you have SMTP. It's also for mails. And then you have FTP, file transfer protocol. For those that do web design, they know about this a lot because that's what you use to upload files to the internet. And then the one that governs the internet itself or websites, that's the HTTP, the Hypertext Transfer Protocol. And the more secure version of it, which is HTTPS. Like I said in the other time, the files are here as well. So when it comes to you, you can read it up. TCP, IP. I jumped it a bit because I know we're going to have time to talk about IP addressing very well later. That's our next class for tomorrow, Saturday. We're going to deal with IP addressing, how you can create, how you can join the computer to the internet or join the computer to the network, make two computers communicate. We're going to look at all of that. So these are the other types of network protocols. You have Telnet, you have Gopher. There are more than this, but these ones are the important ones that I just brought out. Okay, moving forward, the protocol suite itself, a combination of a couple of protocols, commonly known as TCP. There are two of them. We're going to look at two of them. They are models. So the Internet Protocol Suite is known as the TCP/IP. Communication protocols used in the internet and similar computer networks. The currently foundational protocol, that's like the one they said is the base for every other thing happening on the internet. Okay, it can be used on the private network or on the public network, so you can be internal or external. That's what it is, and it has 4 layers: an application layer, a transport layer, a network layer, and a physical layer. On the physical layer, you have Ethernet and the address resolution protocol. That's where some things like DNS fall into. On the network layer, you have IP and ICMP. ICMP is another kind of way. When you hear ping, for network people, when they hear ping, they understand what I'm referring to. We're going to look into that in our next class when we are dealing with IP addressing and diagnosing IP address issues. On the transport layer, that's where you have your TCP and UDP. And then on the application layer, you have all those applications that use end resources, HTTP like the web, FTP for transferring files, POP for mails, and so on and so forth. So this is like a breakdown of it. The application will allow access to network resources. The transport will provide reliable process-to-process delivery of the information of the packets themselves, while the internet layer, the network layer, is to move packets from source to destination, while the network layer is responsible for transmission between 2 devices. So the network layer sits on the device. The internet layer is networking across more devices that handles it whenever it leaves the device, and that's where you have all those routers and intelligent switches. Okay, so this is like a pictorial view of what we've been mentioning. Some of them appear in different places. So you can see the network access layer where you have Ethernet and interface drivers. The internet layer where you have your IP, your NAT, and so on and so forth. All of this is a TCP suite. But remember, I mentioned at the beginning that the TCP is a logical protocol. It is not physical. This is not how the data jumps from one place to place. This is just what logically explains what happened. It's not like you're waking up one morning and say, okay, you want to configure the network access layer and the internet layer and the transport layer, and no. All of these are some of them are just settings. 2 devices connected and they go through all of this. Okay, this gives you examples. So on the physical network interface, you have hubs, you have reps, you have modems, you have L2, layer 2 switches and bridges. On the internet layer, you have routers and layer 3 switches. Transport, you have firewalls, load balancers, or application endpoints or end services, end devices belong to the 4th one. There is a new updated TCP IP protocol. There is no more need for combining the data link and the physical. The NIC and the cabling has been split to give you physical and data link. So that's where we have moved into the updated TCP IP stack. But those 2 layers, the physical and data link, are still merged together somewhat. Okay, so we can put that at the back of our mind so that when we're talking about the IoT interface, you can understand why there's a difference. Okay, now the OSI reference model, the more popularly related one, that divides into 7 instead of 4. It describes a structure with 7 layers for network activities. So one or more protocols can show up in different layers. And that's what the OSI model is about. Okay, now this is what I'm referring to. You have the physical layer and the data link layer. If you notice, the updated TCP has picked up that physical layer and data link layer. Okay, so now you have the network layer, you have the transport layer, you have the session layer, you have the presentation, and finally the application layer. This is what the OSI model talks about, or that's how it views interconnectivity. Okay, the application layer enables the user or the software to interact with the application itself. The layer 6, which is the presentation layer, is the one that translates or formats the data for the application to understand it. The layer 5, which is the session layer, is the one that sets up and controls the conversation between applications. The layer 4, which is transport, is usual, transferring data across a network. Layer 3 moves the data through the network. The transport and the network layer are different, even though they sound like they do the same thing. One of them is the one that provides error checking. That's the transport layer. Error checking, protection, and the rest of them. The other one handles the moving the things, like driving the car from one place to another. The data link layer handles the problems that occur as a result of transmission, bit transmission. While the physical layer, of course, is the one that handles the electrical conversion of the data you're dealing with. Remember, we are referring to IoT. So when there's a physical sensor, the physical layer should be making sense to you when we're mentioning that. Okay, so this is just what it's all about. Application is for end user, presentation is for syntax, the session is for syncing and sending to a port, the transport is for end-to-end connection, the network handles the packets, the data handles the frame, and the physical structure is on the physical layer. This is trying to say exactly the same thing as well. The last one here we're talking about is the combination or the comparison of the two models, the TCP/IP and the OSI model. They achieve the same goal. Data is transferred from one computer to the other. The main difference is that OSI is a conceptual model. It's not totally practical. It defines how applications can communicate over the network. It's not saying it must communicate like this. Now, TCP, on the other hand, is widely used to establish links and network interactions. These are some of the things that we're looking at. Then, other differences that we can see, they are both logical, they are both networking standards. They divide the network into layers. One has 7, one has 4. They enable one manufacturer to make devices and network components that can coexist and work with devices made by another company. Okay, so they provide framework for creating and implementing standards and devices. Now this is a pictorial. Okay, this continues to say it uses just one layer application to define the 3 upper layers of the OSI model. So when TCP says application layer, it's referring to the application, presentation, and session layer of the OSI model. So these are all the differences. They follows the horizontal approach while OSI follows the vertical approach. TCP helps establish connection between different types of computers, where OSI helps standardize the routers, the switches, and so on and so forth. So this is the relationship between them. On the right hand side you have the TCP/IP 4 layer model. On the left hand side you have the 7 layer model, and that's how they relate to each other. The last thing we're looking at today is the network connectivity of the IoT. It's just a few slides. What we're looking at, what we're trying to bring out here is the things we've been mentioning since: our phone, our computer. They are quite they have enormous interface. They have enormous capabilities. They can accept a lot of things. That's different from the IoT itself, minus the phone. Imagine your microwave having to have a network port, or having to connect to a specific type of wireless. Or let's even go smaller, those smaller sensors, their storage is low, their interface is smaller, so they cannot hold as much standards, as much algorithm as a phone or a PC will. And that's what presents some form of problem. So this one says, in contrast to PC, smartphones or similar devices, IoT is normally constrained regarding memory space, access to continuous power supply, and processing capacity. Now this is what limits them. So a new protocol had to be brought up So as a consequence of some of these problems, the lightweight communication protocol was developed, and that's what we're looking at here. According to the OSI model, the lower layers, that's the physical and data link layer, that's where IoT falls into. It doesn't have all the other bigger ones. So in order to integrate IoT into the existing networking environment, there has to be some form of standard that helps those devices out. Okay, now the networking layer handles object mobility and information routing, but the lower layer is where you have a lot of technology changes. The middleware layer facilitates seamless service discovery. And remember that there's networking in IoT as well. So I'm not referring to that networking side of it. I'm talking about the devices themselves now. The physical devices, the sensors, the actuators. That's where I'm referring to. Okay? So every other one can be handled by the gateway, the network. Those ones are not a problem to us. So prominent examples of standardized IP-based communication protocols for IoT is what this is about. So you can see things like COAP and REST. These are different protocols now that are related to IoT alone. You are seeing the CSLO WPAN. You're seeing the semantic OPC UA. You're seeing the UPnP. When we handle the class for connectivity, there are 4 things we haven't talked about that we actually breezed past it. There was a time we did a summary for sensors, connectivity, actuators, and so on and so forth. We're going to come back to those ones and dive deep into them. So when we're talking about IoT connectivity, when it gets to that class, we should be able to talk about these ones more often. The REST, the REST engine, and the MQTT. They will be important to us as we move forward. And these are the very, how would I put it, the 3 most common of the standard networking protocols that exist in the IoT ecosystem. Cellular is not going anywhere. Wi-Fi will not go anywhere, because some of those IoT devices have Wi-Fi modules that they can connect. The Bluetooth as well is not going anywhere. But there are some other new devices or new technologies that has popped up in recent years. I'm going to increase the size of this so that I see and read out some of it to you. You will get the slides and see it for better for yourself. You can see technologies like Zigbee. You can see technologies like N-Ocean. All these are technologies to connect. You've heard of NFC before, the near field communication. There's LoRa, there's LTE. All these are technologies that IoT has been able to use to advance in the ecosystem itself. Okay, now this is the one I need you to put at the back of your mind. LPWAN. We cannot do without that. Low power wide area network. That's what the low level devices for the IoT. That's where they come into play. The Internet of Things ecosystem has been able to use LPWAN to extend the range of connectivity for IoT devices. So your sensor that is used in agriculture, that is buried in the soil, does not need to have a Wi-Fi close to it. The technology behind LPWAN can help you reach the Wi-Fi wherever it is. So it comes in between the regular network that we know and those low-level sensors that don't have the capability to handle a lot of processing. Okay, and that's where we're going to stop for today. Tomorrow, being Saturday, we're going to have a very brief class, and the class would be some form of practicals, although it will be me doing the practicals and you seeing it. And as well, some of us that are using laptops, you can as well check out what I'll be doing so that you follow along practically. and then I'm going to be using a software called Packet Tracer to simulate how you can create such connections. If you are using a laptop and you have internet connection, please see if you can download Packet Tracer. It is free online. Download Packet Tracer and then install it, so that when I start my practicals you can follow along. If you're joining us from a mobile device, you might just probably just watch and see what's happening. A quick review of what we just done today. We've looked at the definition and types of a network. We talked about PAN, WAN, LAN. I mentioned WLAN. We talked about the basic network components. If you still remember the 4 of them: the computer hardware, the cables, the network device, and the computer software. I went ahead to mention network protocols: TCP, UDP, IP, POP, and so on. I talked about the TCP protocol suite, the 4-layered, and the OSI model, the 7-layered. Then I looked at the IoT network and connectivity, some examples of standardized IP-based communication protocol when we're talking about MQTT and the rest of them. And then we looked at LPWAN. If for nothing, if it's just the words, the low power thing that you have to pick up, please pick it up, because we're going to go deeper into the low power wide area network later on. But if it's just the name that you understand right now, and understand that it helps extend the range of your traditional network of the IoT ecosystem, those sensors can now go further. That's what your LPWAN does. Okay, so we've come to the end of today's class. If you notice, there's no assessment, because I want to give you time. Our classes were combined today, tomorrow, so let me give you time to read the material again, go through it again, prepare for my tomorrow's question. I promise to be 20 to 25 questions that we already did like 15 before. We already had like 15 to 20 before. So is that something you should be worried about? So this will be the end of our class. Do we have any questions? Let's entertain questions about what we've just done today, or what you feel we should have done and we did not talk about. Thank God for the question that made me talk about the MAN. I think that question was what brought about me mentioning that. So if you have any question about networking, the theoretical part of it, because I've not done the practical part yet, the theoretical part of it, then let's entertain it, so that tomorrow we will look at some practicals for the computer. At least after tomorrow, you should be able to connect your laptop, your desktop, to a network, join a local network, or create a mini network by yourself in your own office or in your home. We should be able to achieve that by tomorrow. So are there questions that we can entertain? If you have questions, please ask. Remember, not asking me questions makes me feel like you understand everything perfectly. It means I'll have to dig deeper to ask you questions. So if you don't understand anything that I said all this while, please don't hesitate to ask. I hope the internet wasn't much of a problem today, so that we can forge ahead and hope tomorrow will be the way today was, or the way today is. So no questions. Okay, the major internet problem. Someone said, sir, the internet was a major problem for you. Okay, Samuel said internet was a major problem. I'm sorry about that. There's always going to be technical difficulties. Where can I download Packet Tracer? Okay, I would send you a link where you can download Packet Tracer on WhatsApp so that you can instantly get that downloaded. It's a roughly 190 something MB. That's the size of the last time I checked. The last time I downloaded was 190 something MB. Even if it means you registering, it's Cisco. You're registering in the Cisco platform itself. In fact, I would encourage you to register because there are some free things that come with your registration, some free training that comes with it. Okay, the Adewale said internet was a problem for me too. That was why I joined late. Okay, I think luckily I recorded the session, so after I upload to Facebook or to YouTube, I should be able to send you a link so that you can get heads up on what you missed. Okay, the other one has a question. My question is, years back I know of using Bluetooth to connect two systems together. Is that part of IoT? Of course. He says it's Internet of Things, right? Now Bluetooth is a networking technology. It's part of network. Now it enables you to connect multiple devices. Okay, so now some IoT devices actually comes with a Bluetooth module that allows you connect other devices to them, so that works as well. Adewale is saying LPWAN is meant to accommodate IoT newly introduced devices. Yes, both the old ones and the new ones. Yes, it's low power. You know, the low power thing means that sometimes it's just battery powered, sometimes it's solar powered. It doesn't spend much power to transmit information to its destination, and we've been able to achieve a fast rate of transfer even with the low power. Before, if you wanted to transmit faster and better, you have to have high processing power, and then the low power, I'm not talking about electricity. No, that's not what I'm referring to. I'm just saying processing power. So yes, it accommodates both the older ones and the newer ones as well. Okay, any other question? Please don't forget some of the things we've talked about today. Even though our assessment is not today, don't forget them against tomorrow. We talked about those little words: LAN, WAN, WLAN. Okay. Zainab saying you can't hear clearly at all. Sorry about that. Let me ask: is it network on my side? Can others hear me? Because if others are not hearing me properly, it means it's network from my own side. Okay, others can hear me, so it's not network from my own side. Let's try and change location. I know it sounds funny, but it actually works. Sometimes I've been able to notice that my sitting room does not have as much network as my bedroom. I'm still in the office. The network is a bit better than both my sitting room and my bedroom. So changing location helps, even though it's in the same household, but different location actually helps. So sometimes try and change location to see if it works. And then if you're using a particular network and you feel the need to swap to a different network, you can try that out to test if that can help. So if there are no other questions, thanks for joining today's class. I will apologize for the shifts in the class time. It was supposed to be Thursday, and now we're doing it Friday. We'll have another one Saturday. So I apologize for that. We hope that the system is stable now. We'll continue to strive for the best. We'll continue to make sure we move faster than we are currently moving. We should be able to join the rest of the world. That's why the ministry has decided to do this. So we should see some improvements as we go on. Thank you once again for joining. Please, if I forget to send some things across because of probably being busy, remind me on the WhatsApp group, and then I would send it across. So see you guys tomorrow by 4:30 p.m. Have a nice day. Samuel is asking if we're doing a physical class. A physical class is in 4 weeks' time, if I'm not mistaken.